Jai Hind students. So this is my third video on complex topics. My third video is basically on the unit 3, which is Introduction to Multipath Fading and Rake Receiver. So let's start this topic today. Okay, so before going for the rake receiver, let us start with the fading. I mean, why this rake receiver is required. So what is fading? Fading means we know when your electromagnetic wave travels from one place to another. So basically that electromagnetic wave propagation, it will diverge, and it sometimes affect by reflection, diffraction and scattering. And because of these effect of reflection, diffraction and scattering, your electromagnetic wave will not be in that same condition as we transmit at the receiver. So most cellular system operates in urban areas where there is no direct line of sight between the transmitter and receiver, and where the presence of high-rise buildings also causes severe diffraction loss, and because of that your wave will affect from fading. Now we have different propagation models, and we have designed many propagation models which will traditionally focus on predicting the average received signal strength at a distance from the transmitter, and it will vary depending upon the signal strength and the proximity of a particular location. So small scale fading or simply fading, it is used to describe the rapid fluctuations or the changes. Like if we transmit our wave like this, so we will find some rapid fluctuations in the signal because of the reflection, diffraction and scattering. Okay, so these rapid fluctuations are known as a small scale fading, and the amplitude of it will actually fluctuate the amplitude of the received signal, and which will travel over a short period of time or for a short distance. Okay, so we have similarly we have large scale fading also, which occurs because of the large distance. So fading is caused basically by the interference between two or more versions of the same signal which are received at the receiver at different time. Okay, so this signal we have transmitted, but at the receiver because of fading and because of reflection, diffraction and scattering, you are not receiving only one signal at the receiver, whereas you are receiving multiple versions of receiver which are also time shifted. Okay, so these are time shifted versions which we receive at the receiver because of fading are known as multipath. Okay, so these waves are known as multipath waves. Multipath wave means because of reflection, diffraction and scattering from smaller objects, from high-rise building, from small hills, because of that your wave which transmit from one point is received at the receiver at different times. Okay, and in different affected by different fadings. So these waves which we receive at the receiver in a time delayed form is known as the multipath. Let's say this is our transmitter and this is our receiver. Okay, so there would be a direct line of sight signal which we receive at the receiver. Let's say this is our transmitter and this is our receiver. So there is one direct line of sight component which we are receiving at the receiver, and we also receive multiple refracted and diffracted version of the same signal which are affected by these small objects and also because of these high-rise buildings. Okay, so we receive multiple diverted or deflected or refracted signals because of the obstacles which are present in between the transmitter and receiver. Okay, so the wave that we receive at the receiver from different path, this wave is known as multipath. Okay, so it's a kind of kind of delayed version or time spreaded version of the original signal. Okay, so here because of this your wave can vary widely in amplitude and phase depending upon the distribution of intensity and relative propagation time of the wave and the bandwidth of the transmitted signal. Okay, now multipath in the radio channel creates a small scale fading effect. Okay, the three most important effects that we generally see in our multipath wave are: first is the rapid change in signal strength over a small travel distance or a small period of time. Then we see rapid frequency modulation due to varying Doppler shift on different multipath signals. Okay. Third is the time dispersion or echoes caused by the multipath propagation delays. So these are the three major factors which we can see, which we can feel or observe in the multipath. Okay, so here we can see the type of small scale fading. Before going for the RAKE receiver, we should know what all are the types of fadings on the signal. So it is basically based on multipath delay spread and based on Doppler spread. We can define types of fading based upon the multipath delay spread and based upon the Doppler spread. So based upon multipath time delay spread, we have two types of fading. One is flat fading, another one is frequency selective fading. Flat fading is the fading that occurs when the bandwidth of the signal is less than the bandwidth of the channel. So if signal bandwidth is less than that of bandwidth of channel, then we have the flat fading. Or when the delay spread is less than that of the symbol spread. Delay spread means the shifted version of the signal. So the delay, let's say this is small t or the delta t. So this is the delay. So if your delay spread or the delay, it is less than that of the symbol period, then also the fading is known as flat fading. In frequency selective fading, the opposite case is there, the vice versa is there. If the bandwidth of the signal is greater than that of the bandwidth of the channel, then your signal will observe the frequency selective fading. Also, when the delay spread is greater than that of symbol spread, then also your signal will feel the frequency selective fading. So this is based on the multipath delay spread. Next, we can define small scale fading based upon the Doppler spread. Based upon the Doppler spread, we have fast fading and slow fading. Fast fading and slow fading. So fast fading is the condition when we have the higher Doppler spread. Okay, higher Doppler spread is there, then we have fast fading. If we have low Doppler spread, then we have the slow fading. I guess we all know the Doppler effect. Doppler effect means once our transmitter or receiver, if any or both of them are moving, then there will be a change in frequency. Okay, as the distance, based upon the distance. So that change in frequency delta f is known as the Doppler frequency or the Doppler spread. So if we have high Doppler spread, then it will be fast fading. If we have low Doppler spread, then it will be slow fading. Also, if your coherence time is less than that of symbol period, then fast fading. If coherence time is greater than that of symbol period, then slow fading. Channel variations are faster than the baseband variation, then also fast fading. If channel variations are slower than that of baseband signal variation, then slow fading. So these are the types of fadings. Okay, now coming to the RAKE receiver, how RAKE receiver will come into picture if we talk about multipath or fading, right? So we all know that we have different technologies, like we have TDMA, FDMA and CDMA that we all know and we have studied in third unit. So FDMA is frequency division multiple access, TDMA is time division multiple access, and CDMA is code division multiple access, and sometimes this CDMA is also known as spread spectrum. Why spread spectrum? Because what we do, we actually extend our signal or we multiply our original signal with a PN code or pseudo random code, which is a higher bandwidth code. We multiply our normal signal or the data or the information with this PN code, and then we transmit the signal. So this spread spectrum signal system will provide you the high security. So in the case where we want high security, then we use this spread spectrum system. Okay, so in spread spectrum system or the code division multiple access, the chip rate is typically much greater than that of the flat fading bandwidth of the channel. So, whereas conventional modulation techniques requires an equalizer to undo the intersymbol interference between adjacent symbols. So, what is this intersymbol interference? Intersymbol interference is the interference which is present in the two components of multipath. Let's say this is the one component of multipath and this is the another component of multipath. So, there will be some interference because these are the time shifted version of the original signal. So, some part of that signal can collapse. So, because this is known as the intersymbol interference, and in normal TDMA or FDMA technique, we can use equalizer to remove the effect of intersymbol interference. In CDMA spreading codes, these are designed to provide very low correlation between successive chips. So, in CDMA, we cannot use equalizer because of this chip rate which is very higher than that of flat fading bandwidth. So, we go for RAKE receiver. So, here propagation delay spread in the radio channel merely provide multiple versions of the transmitted signal at the receiver. If these multipath components are delayed in time by more than a chip duration, they appear like uncorrelated noise at a CDMA receiver and the equalization is not required. Okay, so if we are using CDMA receiver and there is a condition, if these multipath components which are delayed in time, if this delay is more than that of a chip duration, then these multipath components will appear as uncorrelated noise. So, sometimes there is a case when there can be some useful information which is present in the multipath components. So, we cannot just nullify those components, we have to extract the information from them. So, in CDMA receivers, we have a special receiver. What it does, it combines the time delayed version of the original signal transmission in order to improve the signal to noise ratio of the receiver. See, if we accumulate the information of multipath, okay, in that case we can improve the signal strength. How we can improve the signal strength? Because we are not eliminating that part of the signal. What we are doing, we are extracting the information from multipath. So, this is the beauty of RAKE receiver. It actually exploit multipath and extract the information. Okay, so a RAKE receiver, it is a radio receiver which is designed for the purpose to counter the effects of multipath fading. Due to reflection from multiple obstacles in the environment, radio channel can consist of multiple copies of transmitted signal having different amplitude, phase and delays. A RAKE receiver can resolve this issue and combine the signal. For this purpose, we can see several sub receivers are used which are known as fingers. Okay, so what we use? We use multiple receivers. In RAKE receiver, these multiple receivers are known as fingers. Okay, so here we can see this, this is a block diagram of RAKE receiver in which we have M fingers, 1, 2 up to M. So, it is also known as M branch or M finger RAKE receiver. This is the implementation of M branch and M finger RAKE receiver. Here, each correlator detects a time shifted version of the original CDMA transmission and each finger of the RAKE receiver correlates to a portion of the signal which is delayed by at least one chip in time from another finger. So, here this is RT. RT is actually the IF component or the intermediate frequency component or the baseband CDMA signal with multipath. Okay. Then we have multiple correlators here, correlator 1, correlator 2 and correlator M. Okay. So, what it does, these correlators are the time shifted versions of multiple receivers. Okay. So, here the original signal is time shifted and then we have added some weights here, alpha 1, alpha 2 and alpha M. Then we have a summer, then integrator and then the decision making circuit. Okay. So, here what it does, each correlator detects a time shifted version of the original signal transmission. So, these are the time shifted correlators. So, it extracts each and every bit of your original signal which is time shifted version of the original signal. So we have multiple correlators here, and also we are providing the weights. Weights means based upon the previous observations, we provide some weight so that your signal will be able to detect, right? Because sometimes our signal will not have that strength that it can be detected by the receiver. So what we do, we provide some weights into that, and then we sum or provide the addition of all the components, and then we will integrate it, and then finally this is your decision making circuit, which will decide whether the signal is present or not. Okay, so here RAKE receiver utilizes multiple correlators to separately detect the M strongest multipath components. Okay, so strongest components will be detected by the correlators. The output of each correlator are weighted to provide a better estimate of the two transmitted signal than is provided by a single component. So weight means some addition or some amplification sort of. So this weight will provide you a better estimate of your transmitted signal. Then we demodulation can be done, and the bit decisions are then based on the weighted output of M correlators. Like here, here we do the demodulation and the detection of the signal. The basic idea of RAKE receiver was first proposed by Price and Green. Okay, this is the name of the scientist who actually invented this RAKE receiver. In outdoor environments, the delay between multipath component is usually large, and if the chip rate is properly selected, here the only concern is to select the chip rate, because we have multiple correlators. So how the bandwidth of correlator is decided, that is the important point. So each multipath component, I mean, let's say we have multiple components, okay, and we will see the delay between the multipath component. So this delay will be detected, and the chip rate is properly selected. The low autocorrelation properties of a CDMA spreading sequence can assure the multipath component will appear nearly correlated with each other. Okay, so when the transmitter transmits the signal, then it travels through the environment, which consists of variation in obstacles, and transmitted signal is reflected by them, and it is received by RAKE receiver from multiple paths. Okay, so let's say this is your transmitter and this is your receiver. So we will see multiple shifted versions because of high-rise buildings, because of small trees, because of cars. Okay, we can see multiple versions of the transmitted signal which we receive at the receiver. So for each multipath component, we have one correlator or one receiver. We will not spare any signal if it is detectable. So all the detectable signals are received by all correlators. We have M correlators. This will be depending upon the type of fading, the amount of fading. So that is why your number of correlator will be decided. Then RAKE receiver then feeds them to different fingers. Okay, so all signals are received and all signals are then fed to the different correlators. The delay in each received signals are compensated and fed to the combiner. So here these are detected. Okay, this is received signal and then applied to different correlator, and then delay is detected, and according to the delay, that amount will be given by these alpha 1, alpha 2 and alpha m weights, and then all the signal will be combined all together so that all the signals are on the same pitch. Okay, so delays in each receiver received signal and are compensated and then fed to the combiner, okay, the summer, and then we integrate this and then compare. So comparator means to decide whether the bit is present or not. Then we have the comparator which combines them suitably with different appropriate time delays. So this is how your final signal will be detected. Now these are the advantages and disadvantages of RAKE receiver. First is it will improve efficiency and the performance of a CDMA system. Second, it also improves signal to noise ratio. How it will improve the signal to noise ratio? Let's say if I'll only consider the direct line of sight part which is received at the receiver, and if I ignore all the shifted versions, okay, so it will detect only this signal. Only this signal is detected, only this one. Okay, shifted versions are not detected. Then signal strength will be low because we are not considering other part, although they have good strength also, but they are only shifted in time. So this is how your strength will be reduced. But if we catch all the signal, combine them in the RAKE receiver, then the total signal strength will be increased or enhanced. So that is how we can say that it will improve the signal to noise ratio. Then there can be some disadvantages also. If something is having advantages, it will also have some disadvantages. So the disadvantages are, first is increased cost. Obviously, if you are providing multiple correlators, if you are providing multiple fingers, and then some are, so obviously your cost will be increased. Second, it will also make the system bit of complex. Okay, so complexity has also increased, but yes, it is providing you better signal to noise ratio. Okay, so this is the reference that I have taken, Rappaport wireless communication. Thank you.